Coming up next week, today we're covering 6.3, which is graphing and analyzing graphs of square root functions and inequalities. Monday we'll cover 6.4 on finding nth roots, so square roots, cube roots, fourth roots, and so on. And then that is halfway through chapter 6, so after Monday, we will have a review of 6.1 through 6.4 on Tuesday, and that summative quiz will be on Wednesday. And you'll get your homework quizzes back on Monday as well. So for 6.3, square root functions and inequalities. So in Algebra 1, you did graph square root functions, and you did work with some simplifying radicals, so this is just working more with that. It has just the definition first here. So when a function contains the square root of a variable, it's a square root function, and this is a type of radical function. So the sign that you typically think of as the square root symbol is actually called the radical symbol. If there's no index written here, so for example, I know we also had looked at cube roots in the last chapter when we were factoring sums or differences of cubes. So if there's no index written, it is a square root specifically, but the symbol itself is called a radical symbol. So square root functions are radical functions. And what I have included on here, this is for you to be able to recognize when you graph a square root function, what should the graph look like. The information that is given here is specific to the parent function and not for every single square root function. So the parent function of a square root function is just the simplest square root function there is. So that's just if you have f of x equals the square root of x. And then it shows the graph of that function there. So note the shape. I had briefly mentioned when we were graphing inverse functions and you had graphed that sideways parabola. I said a square root function is half of a sideways parabola. So hopefully you can see that from how it's drawn. But all square root graphs will have, and however you want to name it, I'll refer to it probably a few different ways, but they have a starting point, an end point, however you want to call it. So I'm just going to put here, I'll put starting point slash end point. It's also thought of as the maximum or the minimum of a square root function. So for this particular graph, because the graph is starting at 0, 0, and then it curves up, so 0, 0 would be the lowest point. Square root functions can also curve down, in which case then it would be the highest point, so it'd be the maximum. So they will all have a starting point or an end point, and then will either curve up or curve down, but will have this same shape. So none of your graphs today should end up being lines. That's a big thing for these. So then it does give the domain and the range for the parent function. And again, note the domain and range will not always be these. It's just this for the parent function. So we'll be talking about actually first how to find the domain and the range. But for the parent function, since this starts at 0, 0, the starting x value is 0, and then it continues for all x values greater than 0, so that's why the domain is x greater than or equal to 0. Starting y value is 0, and it curves up, so all of the y values are also greater than or equal to 0. So remember, f of x just means y. It also, I'm not really going to be asking you for the intercepts or where it isn't defined or end behavior, but it does give that information for the parent graph. Something to point out, though, where it says not defined. So remember, for a square root, you cannot take the square root of a negative number. That would be imaginary. We do not graph, or we cannot graph imaginary numbers on a coordinate plane. So whenever the x value is less than 0, that's why it's saying it's not defined, because you can't take the square root of a negative number. And then it gives the end behavior, which is just saying one end is just approaching 0. The other end would be slowly approaching infinity. Okay, but I'm not asking you in this chapter to identify end behavior for your square root functions. I will ask you to graph them. I will ask you to find domain and range. So in the first set of examples, Well, it says above example 1, the domain of a square root function is limited to values for which the function is defined. So we're going to go through both A and B together, how to identify what the domain and range are for a square root function without looking at a graph. So I'll actually refer to this as we go through A. We're going to find the domain first. But notice in the parent function, so you have the square root of x, and that means the x, because it's in the square root, has to be greater than or equal to 0. It can't be negative because you can't take the square root of a negative. So in general, to find the domain of a square root function, you take what is inside the square root and only what's in the square root. And you say, in this case, for part A, x minus 3, because it's in the square root, has to be greater than or equal to 0. So you're setting up an inequality that you can now solve for x to find your domain. So if x minus 3 has to be greater than or equal to 0, if I add 3 to each side, this means then for my domain, my x values have to be greater than or equal to positive 3. So if x is a number that's less than 3, then I would get a negative number in the square root. And therefore, the domain is only if x is greater than or equal to 3. So finding the domain, you set what's inside the square root symbol greater than or equal to 0 and solve for x. And then to find the range, so I'm going to again refer back up here. So notice that this parent graph starts when the x-coordinate is 0. So what we need to find for our function in A is if our starting x value is 3, we need to find our starting y value and then write the appropriate inequality for the rest of our y values. So to find the starting y value, what you want to do is substitute whatever x value you get here in your domain back into your function. So I want to find f of 3. I'm just going to draw an arrow so you can see where that 3 is coming from, and that just means I substitute 3 into the square root of x minus 3, so I get the square root of 3 minus 3. And I evaluate this to find that starting y value. So inside the square root, 3 minus 3 is 0, so I get the square root of 0, and the square root of 0 is just 0. And that's my starting y value. So then here you have to determine, and we'll be talking about this throughout our examples, if the range is going to be y values greater than or equal to 0 in this case, or less than or equal to. And when you don't have a graph to look at, how you can tell, and I'll talk about it more when we talk about this box down here as well, is by the sign that's in front of the square root symbol. So I know there's not a number written in front of the square root, but if I had to write a number there, there'd be an invisible 1 in front of it, 1 times the square root of x minus 3. But that 1 that's in front of it is positive. So if the number in front is positive, that means the graph has a starting point and then curves up, which means your y values are going to be greater than or equal to the starting y value. So in this case, the range would be y is greater than or equal to 0. So if this was a negative in front, and we will go through at least one example that does have a negative in front, but if it was a negative, then my range would be y values less than or equal to 0. So that's a way to tell if you don't have a graph to look at. Okay, so any questions right now on A, how I found that domain or range? We're also going through B together. Okay, so for B, so this is f of x equals the square root of x plus 6, and then plus 2. The plus 2 is not inside the square root. So again, to find the domain, you only take what's in the square root and set that greater than or equal to 0. So to find this domain, I would say x plus 6 has to be greater than or equal to 0, but the 2 isn't part of it at all. And then solve this for x, so I would subtract 6 from both sides. So for the domain, x would have to be greater than or equal to negative 6. And then I need to find the starting y value for the range. And I can find that by substituting the negative 6 back into the function. So finding f of negative 6, So that would be the square root of negative 6 plus 6, and then the plus 2 is outside of the square root. And so when I simplify this, I need to make sure that I'm simplifying using order of operations. So I simplify in the square root first, negative 6 plus 6. So I have the square root of 0 plus 2. Then take the square root of 0, which is just 0, and 0 plus 2 then is just 2. So my starting y value is 2. And then again, if I look in front of the square root, again, there isn't a number, so there would be an invisible 1 there, and it's positive. So for my range, the y values are greater than or equal to 2. Okay, and now I'm going to be still referring to these two examples. I want to talk about the key concept box, the transformations of square root functions that's on the bottom. When I have you graph square root functions, I'm not having you graph by describing the transformations. I just think it's helpful for you to have an understanding of what transformations could be taking place. And then even though I'm not having you describe the transformations, it's still important for you to be able to identify in this formula given here your values of a, h, and k, because they do mean something specific on the graph. So this function here, you want to know. So this is the general form of a square root function. F of x equals a times the square root of x minus h plus k. Hopefully that looks familiar to you, because what I have written on the board up here is a formula very similar to that one that you have seen before. So y equals a times the quantity x minus h squared plus k. So this was the vertex form of a parabola. So here, a, h, and k function the same way in terms of transformations as they did for parabolas. So how a, h, and k transform a square root function is the same as how they would transform a parabola. Now obviously the two graphs look very different, but again the values function that same way. So here in a parabola, this is called vertex form because the vertex was the ordered pair hk. So if you knew what hk was, you could identify the vertex really easily. hk is also a specific, or I guess a very important point in a square root function. hk for a square root function is the starting point or the end point. So when we go through an example of graphing a square root function, you want to identify h and k first so that you know what that starting point is. And then what I want to talk about, and I want to highlight a few things here, is also how h and k and a can help you identify the domain and range. So h, overall, the value of h represents a horizontal translation. So h would translate a graph left or right. If h is positive, it would go to the right. If h is left, it would go, or h is negative, it would go to the left. The important thing for you to note here is for every square root function, the domain will always be x values greater than or equal to whatever h is. So if we look back up at the two examples we just did, for a, and again, this is the same, hopefully you're kind of remembering this with parabolas, since it's x minus h in the formula, h is the opposite sign of what it appears to be in the function. So for a, when I see x minus 3, h is really positive 3. And notice your domain was x values greater than or equal to 3, and your h is 3. For part B, you see x plus 6, so h is really negative 6. Your domain is x values greater than or equal to negative 6, which is your h. So that's another way to identify the domain. If you know h, it's always x values greater than or equal to whatever h is. Yes. Yeah. Or even the next examples, I'm having you graph and then state the domain and range, so you could still use that same thing here, that same shortcut. And so if you had that and you had no work, it really would take then no work to find the domain if you know what h is. You would just write down x is greater than or equal to h. K is a vertical translation, so the k value translates a graph up or down, up if k is positive, down if it's negative. And then this is kind of what I was talking about by writing those ones in front for the range. K helps you find the range. So I'm going to highlight these two lines here. So the top one says if A is greater than 0, so if A is a positive number, like in both of our examples, the A value, because that's the value multiplied in front of the square root, the A value is positive 1 for both of them. So if A is positive, then the range will always be f of x or y is greater than or equal to whatever your k value is. So in our two examples, or if I look at example A, k is always added or subtracted outside of the square root. There wasn't anything for A, so there would be an invisible plus 0 there, so k would have been 0. And notice our range was y values greater than or equal to 0. And then for B, the plus 2 at the end is the k value. K is positive 2. The range was y values greater than or equal to 2. So that's a shortcut to find the range. And then this didn't happen in either of those two examples, but if the A value was negative, like I talked about, if either of these were negative 1 or any negative number, then the range would be y values less than or equal to k. So the A value determines if it's greater than or equal to or less than or equal to, but it's always around the k value for your range. And then what A is really doing to the graph, if A is negative, that's a reflection across the x-axis, so that means rather than your square root function having a starting point and curving up, it's going to have a starting point and then curve down. And like I said, we'll go through an example of each where it curves up or curves down so you can really see those. And then A also could stretch or compress the graph vertically. So if the absolute value of A is greater than 1, it's going to be stretched out, so it's going to be a steeper curve, versus if the absolute value of A is a value between 0 and 1, so a fraction that's smaller than 1, it's going to be compressed. So for example, this graph here is not very steep, but if A was a fraction between 0 and 1, it's going to be even less steep. It's going to curve even slower. So that's kind of, as long as you have that understanding, it helps when you make a graph and you're thinking, does this look right? Should it really be this steep or should it really be this flat? And then you can kind of tell from the A value if that seems appropriate or not. So we're going to go through some examples. I'll show you really what I'm looking for in terms of work and what I would want you to know when you're graphing these, but that information is more for you to understand when you're graphing them. So looking at example 2, we're going to graph y equals 3 times the square root of x minus 4 plus 2, and then state the domain and range. And I usually graph these by making a table. But as I had stated before, your starting point is the ordered pair HK. So you want to identify HK first. And we can identify A as well. But looking at our function, what is our H value? H would be positive 4. And then K is 2. That leaves the 3 that's multiplied in front, that's the A value. So the very first point that I would put in my table is the ordered pair HK. H is your x value, K is your y value. So the starting point is 4, 2. And then this also helps you determine what other x values to plug in, because now the only other x values that you should plug in should be values of x that are greater than your starting x value of 4. So I should only plug in values that are larger than 4. And how many points should you do? I usually would graph between 4 and 5 points. If you only graph 2, you're probably going to draw a line. And these are not linear. These are curves. So I would say at least 4 or 5 points to get a good shape of your curve. And then using a calculator, some of your y values will be decimals. So I would recommend right now, whatever calculator you have, make sure when I'm going through these that you can get the correct y values on your calculator, and if you can't, when you have time to work, I can help you out. But I don't want you to get something wrong on your quiz next week just because you weren't sure how to type it into your calculator. So, and I know different calculators work differently. So on the calculator that I'm using, I can just type this whole thing in and just replace the x with whatever value I want to plug in. I know some calculators you have to type in one operation at a time. So that's why I'm saying make sure right now that you can get the right value, and if not, I can help you. But I would type this in as 3 times the square root of, and then I want to substitute 5 in first. So 5 minus 4. Now make sure if you have a calculator like this, because that left parenthesis comes up when you type in the square root, after the minus 4 you want to close your parentheses because the plus 2 at the end should not be in the square root. And if you don't put the parentheses there, it will think the plus 2 is still in the square root. And then if I hit enter, so when x is 5, the y value is also 5. So if you are following along on your calculator but you're not getting 5, that's what I want to know. When you have time to work, I can help you figure out maybe what you're not typing in correctly. Okay, and then I can substitute in 6, and I don't have to retype everything. I can just go up into what I entered and replace the 5 with a 6. So this is where when you get a decimal, do not round it to a whole number. I would say 1 or 2 decimal places. That doesn't really matter to me. I'm going to round it to 2, so this would be about 6.24. And then I can substitute a 7 in. And to 2 decimal places would be 7.20, or to 7.2, since the 6 rounds the 9 up. And then substitute an 8, and that y value is also 8. And again, when you plot your points, you should see a curve. You should not see a straight line. So when I graph this, I'm going to plot my 5 points that I have. And remember that 4, 2 is where your graph starts. So when you're actually connecting your points, you shouldn't be going through that point completely. You should be starting there and drawing your curve in. Okay, so this is a steeper curve because of the a value of 3. That's stretching it vertically, so it is a lot steeper than the one that was on the front side of the sheet. But I start at 4, 2, and I just draw a curve through those points, and then make sure there's an arrow at the right end of it. And that's a graph of that square root function. Okay, and then identifying domain and range. So when you have a graph, so you have both of the methods that we talked about on the front. You could find domain and range how we first found it for the examples on the front. You could use the h and the k values. When you have a table and graph, you can also use those to help you. So table, I find easiest to look at since we already have it. For the domain, you can see your first x value is 4, and all of your other x values are larger than that. So the domain would be x values greater than or equal to 4. And then for the range, the first y value is 2. All of your other y values, again, are larger than that. So the range is y values greater than or equal to 2. So you can also use, a table to help you identify domain and range. But domain and range will always be inequalities like this for square root functions. You will never have all real numbers for either of them if it's a square root function. Okay, questions at all on example 2? Okay, and then the last example, because it is a little different, it's a square root inequality. And we graph square root inequalities using the same methods as we used with graphing linear inequalities or quadratic inequalities. So there's 2 main differences between just graphing an equation and graphing an inequality, or 2 things you need to remember when you graph inequalities. Anybody remember what at least one of those 2 things is? Or maybe you remember both. When you graph an inequality, what do you need? Yeah, so sometimes the line or the curve is dotted, sometimes it's just regular, it's solid. How do you know when it's going to be dotted or dashed? Ethan? So if it's a line underneath, so if it is one of these, then it's dashed or solid? Solid, so then if there isn't a line, it's dashed or dotted, however you describe that. So really you just need to pay attention to, is it going to be dashed? Because normally when you draw curves, then you're drawing them solid. So just make sure you're paying attention to that. And then what else you need to remember if it's an inequality? Something you don't have to do when it's just an equation. What's the other difference between the graph of an inequality and the graph of just a regular equation? Something you have to do for inequalities that you don't have to do for equations. What did you say? Oh, here. Nope, that would only be if it's a parabola that you would find that. Shade, yes. So all inequalities, whether it's a linear inequality, a quadratic inequality, an absolute value inequality, a square root inequality, anytime you are graphing an inequality, that's when it's either solid or dashed, and you have to remember to shade. But those are two things you never have to worry about if it's just an equation. So how we're going to graph this, we start out the exact same way as up here. I would encourage you not to work too far ahead with this one though. So if you're working ahead on the table, just wait, because along with these two things, there's slight differences when it's in a square root versus other graphs along these two lines. So I'm going to set up a table. And for this square root inequality, what is our h value? -2, yes. And then k? -4. And then there is a negative in front of the square root symbol, so a is -1. So that means this one is going to be starting and then curving down. That's what you should see happen. So in the formula, it's x minus h, so h is the opposite symbol that it appears to be. Because if it's x plus 2, it's really x minus -2. So then, let's see, -2, -4 is our starting point, hk. All of the other x values I substitute in should be bigger than -2, so I'll plug in -1, 0, 1, and 2. And then don't forget about that negative that's in front of the square root, so I'll take the negative square root of, I'm plugging in -1 first, plus 2, close the parentheses, and subtract 4. So that y value should be -5. And then I can substitute in 0. And that will be approximately -5.41. Then I'll substitute in 1, and that's about -5.73. And then substitute in 2, that y value is -6. Okay, so then when I actually graph this, am I going to have a solid curve or a dashed curve? Dashed curve. Now, along with that, your starting point, if your curve is dashed, your starting point needs to be an open circle. Okay, so at -2, -4, I would want an open circle there, not a closed dot, bless you, because it's a dashed curve. So that means any point on the curve, including the starting point, the point itself is not actually a solution, it's just kind of a boundary. So that's an open circle. The rest of them you can plot as dots because you're going to be drawing the curve in as dashed. So you don't have to worry about that for the rest of them, but that first one, because you can so clearly see it, needs to be an open circle. And then you can draw your curve in, make sure it's a dash. And notice when you draw this into, the first curve was pretty steep. This one is not. Make sure that you're not drawing it so that it goes down and starts to come back up. So it doesn't ever come back up. It is slowly still always curving, always decreasing in this case, just very slowly. So make sure you're not drawing it that it starts to come back up. And then for the shading, so notice usually when we would graph a line or a parabola, we drew it through the entire coordinate plane, so it split the coordinate plane into two different parts, and we would test a point and then determine which part to shade. There's no separation of parts on this coordinate plane because everything is open. A square root function doesn't completely go through the entire graph. So for shading, you don't need to test a point for these. Instead, you look at your inequality symbol. This is the less than symbol. So if your symbol is less than or equal to, you shade below the curve. If it's greater than or equal to, you shade above it. Now along with that though, you do not shade anything to the left of your starting point. So because we're shading below the curve, what I'm going to do is from my starting point, I'm just going to draw a dashed line vertically down and not shade anything to the left of that. So I'm only shading to the right of my starting point and what's underneath my curve. And I would do the same thing, draw a line above it if I was shading above the curve. So even though the overall inequality process is the same for square roots, there are slight differences just because of the type of graph that it is. Questions on that? Okay.